Yeah, you want me to do that? I don't know.
You can make the pumpkin a focal point.
Yeah, exactly.
I'm not sure how someone got a pumpkin, but we've been leaving it here the whole time.
Yeah, but I didn't get a pumpkin.
So this is your.
Let us bring this into the cloud.
We're gonna migrate this pumpkin to the cloud.
So,
You like this background? You want something different? There you go. That would be cool. Coolest thing. There's a way. There you go. Fix the hair. You got it. Oh my god.
I just happened to live 15 minutes down the road from you.
I'm trying to get you like up to speed. I'm starting to get okay with articles. I kind of know how to do the scripting. I'm just not sure how I was doing internet communications because it just has a button on the right.
No, I think we're going to.
Once I figure it out, I will bring it up. But right now I'm still trying to like get my bearings, so I can't really tell you anything because I'd probably be like, oh, so bad. I still don't know.
And also, if anything, I would have triple make that.
I remember I said, right?
If I go down the route of doing maths and moving philosophy, that kind of thing, I will be forever kind of like unable to.
I know a thing or two about that.
That's sad. That's why I feel like I want to learn so much. How's your game? If you think about it, major innovations are always on hardware. At least like, you know, it's like the game changer about, like, I don't know, so like, hardware is like where significant things happen. That like cause paradigm shifts. Right? The internet is hardware. Like, without that, you don't have yeah. But the things to cause like really big like societal changes all hard. And the other one, okay.
I think there is some hardware.
Yeah, but it's constructed with wires. It's like if you don't have the hardware, it's so hard to That's true.
I'm fried, I think.
Can I be heard okay? Can you hear me up there? You can hear me? Great. You can hear me too? Okay, great. So I'm going to go ahead and get started here. So this talk is called Productionizing Your Hackathon App with Amazon Web Services. I don't know what y'all expect necessarily, but we'll talk about what you're going to get here in a second. So, hey everybody, I'm Dan. I work on Amazon Web Services. I'm a systems development engineer. So I am a software engineer who focuses on the infrastructure and automation that underlie the operational live systems. So the things that make AWS services run under the hood, the infrastructure, deployments, all of that. I work on the automation and tooling and maintenance of those systems. So I've been at AWS for 2 months, but before that I was at a company called EF Education First, working on their SRE team, that's Site Reliability Engineering, where I worked on migrating systems from legacy data center applications into Amazon Web Services. managing those systems in live, building out development pipelines, writing tooling, just working with a bunch of different things. So that was super fun. Okay. So what's the intention here? Just want to first I'm going to touch on a couple of concepts that I think we should all just have before we talk about what productionizing is and how that might look with Amazon Web Services. Talk about an example architecture. I'm going to start at the very beginning of the base of what you might want for an application, and then work my way up all the way to delivering that application to your customers and monitoring it in production. And then, this is all infrastructure as a service, which is what Amazon Web Services offers you, and I hope that you come out of this with a feeling for the kind of power that these systems have for building large-scale production applications, even as a small team of people or a small company or an individual even. So I realize that there's a lot of Internet of Things focus here. I'm not really going to talk about IoT. There's a ton of very Internet of Things specific services and pathways available through Amazon Web Services. I don't really know much about that, so go out there and learn about it if you need it. And this is definitely not exhaustive or definitive. This is one person's view of how you can do this, and I hope it's useful to you. All right, concepts and a bit of philosophy. So what is production? When we talk about production, what the heck does that mean? You write an application in class, or you write an application for yourself and you're running it, you're sharing with your friends, your classmates. There are different standards when you have a customer who perhaps even has a legal agreement with you for how available that service is, or you are expecting a cash flow from that application running. You have different motivations for maintaining it actively. So this is in production, this is a live system. There are expectations around your uptime, the security of that system, the consistency, availability of that system that you have to meet. And that's a real challenge, and it's helpful to start at the beginning when you're designing something for production and not have to shoehorn in a lot of stuff later, like monitoring and logging and scalability and being able to configure it with zero downtime. And every serious app, no matter how elegant it is in and of itself, it needs to be reliable and accessible for it to be a true product. All right, so development, I think y'all are familiar with development, but this is the whole process of conceptualizing, developing requirements, designing an application, writing the software for it, and then testing that software. I'm sure that you do it every day, and you're doing it here today as well. So, and then operations, this is a lot of what I do, and I think every developer at Amazon also does this, because there's a really great shared model of ownership over your software. So what it actually takes to run that software, to ensure that it is available to your customers, deploying it, so taking it from a version control repository like GitHub and running it through tests and verifying it and then moving it out into the world and making it available to your end user, your customer, or other consuming services. Change management, it's super important to let people know when your system is changing. That's a huge part of operations. Incident response, when things break and your phone starts to explode because people are noting that this supposedly high uptime service is down, you have to have a good way of thinking about that, responding to it gracefully, communicating to your customers, and figuring those problems out. And then tooling for all of the above, because you don't want this to be manual. You want to build software to do this work for you, right? So here's operations in action. This is how I feel at work, like I'm running a nuclear power plant. Lots of switches and dials and things. So then this sort of brings me to this very fuzzy concept of DevOps. No one has there's tons of answers for what DevOps is, but the idea, and I think Amazon does this really well, is that development and operations are one and the same. You build it, you run it. If you are designing software, you should know how to operate it. You should know how to and be responsible for responding to incidents that occur with that software. And it breaks down this silo between development and operations. I think a lot in the past, People would develop software and then toss it over this like mythical wall to people who would operate it, and there would be very little communication in between, and that would result in a lot of hardship for the people who were operating it, and it would result in unclear requirements for the people developing it. So by eliminating that, unifying teams, and having the people who both develop and operate software working together, you can move a lot more quickly through the process, you can have a more stable process, and you can just have a better product and a better working experience for everyone, I think. But DevOps is characterized by a very high level of automation as well. Ownership over operations and infrastructure, removing these silos and like constant feedback loops and communication, whether it's about how something works well, doesn't work well, metrics, logs, whatever. All right. And then architecture. So another, kind of fuzzy concept. I pulled this quote I love out of Bob Martin's book, Clean Architecture, that the goal of software architecture is to minimize the human resources required to build and maintain the required system. So you want to be designing a system from the beginning, right? It's important to learn how to write things and like learn how to code, obviously, but you want to be able to design a system independently of the specific technologies, and you want it to function in a way that is minimally resource intensive. That's really the goal. You should shoot to operate it with as few people and as few systems and as little compute as possible. Only use the amount of processing power that you need. Don't use one bit more. Don't use 1 person hour more than you need, even if it's cool. All right. So with those concepts sort of anchoring us, so let's talk about application architecture. Of course, on Amazon Web Services, the world's best and only cloud platform. Just kidding, but it is the best. So what's in an application? There's a bunch of stuff, but I'm going to talk about sort of the presentation layer. So that's going to be, well, in this case, we're going to talk about it in terms of like where your users interact with your app and how they hit that. The compute, which is going to be processing the actions and doing the back-end work, storage, storing your data, whether that's a database or bucket or a data lake or whatever you want. Networking, I'm not going to talk a lot about networking. As another disclaimer, you're going to see a bunch of graph or like charts and diagrams in a second. I left a lot of the networking out because I felt like it was too much unnecessary detail, but know that I'm glossing over that, and that's very important. But there's a ton of great white papers and a ton of great tutorials online that I'm sure you could use to just fill in those gaps easily. Monitoring and deployment, so these pieces of operations, like how do we view and observe the application in production, and then how do we get it to production? So I was trying to think of a clever idea for what my example app could be. I didn't think of one. So this is basically just going to be a web application, like a basic web application that you would interact with through your browser, right? And then it would, let's say it's LinkedIn. All right, so this is our example architecture. So I don't know what you're familiar with, so I'm just going to go through this real quick, but we're looking at an API which serves the content of the application, looking at using the JavaScript framework Node.js as the backend, which will be on the backend compute. React is a modern JavaScript framework for front-end development. It's incredibly cool and powerful and just really, really neat. So we'll use that on the front end. And then I just chose PostgreSQL as a relational database for the back end, just because, we all need relational databases, I guess. If you want to understand transactions and how people, and data connect, that's a good way to do it. And it's pretty straightforward and well understood. All right. And then for our infrastructure layer, we're going to be using a bunch of Amazon services. So EC2, Elastic Compute Cloud, is the sort of flagship Amazon compute service. It's servers. They're servers in the cloud that you can get in any flavor and size that you would like, and you can get as many as you like. You pay for them on a metered payment, so it's by the minute you pay. And there's a lot of great features there. RDS PostgreSQL, so that's relational database service. That's an Amazon service that provides relational databases. Application load balancing, this is super important for scale. So a load balancer divides traffic among different backend hosts or whatever, so that you don't end up with one huge server that deals with everything. You split out the traffic among a variety of systems. CloudFront, this is a content distribution network, so this is actually going to be allowing us to deliver our application to people in geographically dispersed locations with minimal latency and in an effective way. CloudWatch, this is monitoring, so Amazon's monitoring service. All the other services integrate into this, and this is one of the amazing things. You get this not for free, you pay for it, right? But you basically can get logs and metrics for any of the Amazon services that you use in one place that you can then build automation and monitoring on top of in order to build really strong, robust production-grade services without having to integrate third-party logging frameworks or third-party alerting frameworks or like wedge things together on your own. So that's really powerful. And then I just slapped code deploy in here. This is a tool for deploying code from your version control to live production services. So we'll talk about each one of these a little bit. But really this is about talking about like, what is a web application? What is a web application architecture? And like, how do you build it up from the beginning to the end? So we're just gonna start here, right? This is like the most basic elemental piece of what you're gonna be doing. This is a single server running Node.js. I've sort of adopted this convention of having the like icon of the service next to the icon of the like framework or technology that it is running on, or that is running on it. So we're saying we're gonna have Node.js, like a node server, and it's gonna be running on a single EC2 instance. There you go, you have your API, like you're gonna take over the world now. Not really. That's great for like getting started and for proof of concept things, totally great. But this is completely stateless, right? There's nothing retained. You're gonna hit it, it's gonna maybe give you some hello world back, but this is the basis of what your application is gonna do. So we need some data with that, right? Like we need to actually be able to serve something up. So we're gonna add some data persistence. We'll add a data persistence layer to this in the form of Amazon's relational database service running PostgreSQL. So that's a open source relational database. It could be anything you want. Amazon also has Aurora, which is a really powerful service.
Just a question.
Yeah.
Just a question about RDS.
Yeah.
If I'm developing a web infrastructure, why would I want to choose RDS instead of running PostgreSQL on an EC2 server, for instance?
Yeah, so RDS actually manages the EC2 instances behind the scenes for you and gives you a really easy way to do things like scale out, scale up, upgrades, backups, all that. It eliminates a bunch of operational overhead.
But then that would increase cost, though, right? As from my perspective.
Sure, yeah.
For the sake of the operations.
Right, it would, but I think that's sort of like the math you have to do with managed services is like, what is the balance between the cost of the managed service, the premium that I'm paying for that, and then the cost of paying individuals to come into work every day and execute on this. And especially if you're running a small company or you're just like launching a new idea, there's a lot of nuance to some of this operational stuff that these services abstract from you, and that can be super helpful, honestly. Like, yeah, I like running my own things from scratch and like building them up and learning everything about them, but you'll find that there's just not enough time in the day. Yeah, that's sort of my view. Cool. So there we go. We've got an inventory now, or let's say we're pretending to build LinkedIn. We've got like, users and their profiles and their associated jobs and their, whatever your data model is on here. And it's connecting to your application, your Node.js API. People are calling that. They're using curl to call it, and they're getting back some information. That's cool. Great. But we want to actually like show this to people who don't use the command line, right? So we're going to want to add a front end. In this case, we're looking at, and this is a simplification also, all of this is a bit of a simplification, but we're looking at adding another EC2 instance. So we've got another server. We're going to put Nginx. Nginx is a web server and a reverse proxy that'll allow you to rapidly serve web content. And it's serving a React application, which is your users are going to hit this box. They're going to get that app, and it's going to communicate back, right, and hit the API. You've got a full application, a front end, a back end, a database. You have users. They're connecting to this. Like, this is a true application. Now, this is really good, right? This is a great place to be. But what happens when you go from 20 users to 20,000 users, or 20,000 users to 20 million users, to 100 million users? Like, how do you get there, right? That's it. That's sort of the next step. This is the basic N-tier web application architecture. There you go. You've got it. Done. Now we got to talk about things like scalability. So this is where the application load balancing and EC2 auto scaling come in. So auto scaling basically lets you, specify a group and say, I want 100 instances, or I want one instance. And then if the queue length exceeds X, scale it up. If the CPU utilization exceeds X, scale it out, so that you can pay for exactly the amount of compute you need to process the requests that are incoming. It will automatically stand up new servers, add them into your group, and direct traffic to it. Application load balancing is a core piece of Amazon infrastructure. It's going to take your user traffic and direct it to the instance with, say, the least traffic on it. Or whatever. There are several algorithms you can choose to have it direct traffic to specific instances. So we're going to do that for our front end. We're going to do it for our back end. So this is great. We're able to support a ton more users now, right? This is an actual scalable application. Now, but what about the database? We're sitting here, we've got this, sort of indeterminate number of front end and back end instances that flux with the amount of traffic that we're getting, but the database is staying static. So we're gonna have to do something about that. RDS provides a lot of good functionality. So in this case, we've got like a master database. We have a standby, hot standby, and then we've got 3 read replicas. So in this case, if let's say, you're serving a menu for a restaurant or something, nobody's going to be changing that. They're just going to be looking at it. So you don't need a lot of throughput for writes to your database, but you need as much read as you can possibly get, because all it is read. There's not a lot of update or delete happening, or writes. So you have multiple read replicas that are synced to your master here, and all your read traffic from your back end is getting directed to these read replicas, whereas, write, update, and deletes are getting written to your master here. So this way you can scale out your database a lot more effectively and provide better performance generally to anyone who is accessing your database. Cool, so now, everyone on the East Coast can access your website. Literally everyone on the East Coast can access your website with minimum latency. Like, what's next? It's the world. Everyone in the world. So if you want to go global, right, or you want to go international or even regional, we're going to be looking at using a CDN, or a content distribution network. So in this case, we're looking at Amazon's CloudFront. So this is a cache. It's a geographically distributed cache where your front-end assets are going to end up in Amazon data centers, point of presences, POPs, or endpoints geographically. So we've got one East Coast, West Coast, EU, Southeast Asia. And this means that you can customize content based on geographic access in a more consistent and scalable way. And you also reduce latency because you don't have people who are in Kuala Lumpur trying to access data centers in, Northern Virginia, and it takes them, 3 seconds to load your page or 5 seconds to load your page, which is frustrating and poor performance. So you have these points of presence in geographically distributed areas, and this accelerates your application dramatically, right? So now you're actually looking at a fully scalable web application that has global geographic accessibility with reasonable latency. Like, there you go. You have a global web service right here. And these are all Amazon products, and they are all available to anyone, right? Like, with the right knowledge, a single individual could build this architecture using Amazon Web Services. It's going to take more than that to operate it, but it's doable. Cool, so now that we've talked about scalability in your actual web application, we're going to jump from development in a little bit further into operations. So monitoring, I'd mentioned CloudWatch earlier. Like, you have this global web application, what are you going to do if it starts to break, right? This is a pretty complex distributed system. So you have a single point of aggregation for a lot of the information coming out of your app in terms of CloudWatch. So logs, metrics, things that tell you like how many 500 errors are your users getting whenever they try to access your website, right? Like, what's the latency for your database? How many instances do you have in each of your auto-scaling groups? Are there failures to scale? Who's hitting which points of presence, and are they getting overwhelmed? You can aggregate this all in a single place and view it through a set of really powerful tools for analyzing data, understanding these systems. And this is really powerful because every single one of these things integrates into CloudWatch and lets you view and understand it through that. And that can't be understated how powerful that is, because you'd have to build it yourself otherwise. Cool, so now that we're like observing our application, right? Like, what do we do with that data? So there's also alerting in CloudWatch, which is separate from monitoring. Like, you can monitor everything and then just have it like go into a black hole and, you know, send it to dev null, and it doesn't matter. Like, great, my application's failing, I don't care. But no, you don't want that. So you can like set up thresholds for alerting and then integrate this through Lambda and simple notification service to send emails, throw Slack notifications. Chime, anyone? Chime? I prefer Slack, but this is an awesome way to actually in real time see how your application's performing and be able to get a quick response time to incidents that emerge from it because of, you know, degraded performance, geographic issues, outages, you know, code, whatever. Like, somebody pushed a deploy and it's failing. You want to know, this is a great way to do it. There are services to help you do that. Awesome. So great, now we're monitoring this thing. Now we've got a bunch of people who are responding to the issues that come up as this globally distributed web application runs. So how do we get our code there? I'm not gonna, this is like a whole talk in and of itself, and I'm not gonna go into it in too much depth. And I am using GitHub here, because I'm guessing a lot of you use GitHub. Y'all use GitHub? Yeah. So this is Amazon Code Deploy. This is a system by which you can take code that is structured to be deployed with Code Deploy and send it out onto your EC2 instances or to a fleet of containers if you're instead using Docker on Fargate or on ECS, or you're running on Kubernetes or something like that, or like Mesos or whatever, you know. It'll package up your code for you and help you to get it out onto these instances. It's part of a larger suite of tools, including code pipelines, which is a whole system where you can build pipelines to automate the testing and deployment of your code. And that's a whole big thing. But so this is actually like getting that code out there, right? Because we have to be able to constantly update it in response to consumer requests for new features and new work. Awesome. So, I mean, that's it, except for one more thing. And this is another really cool thing, and another whole talk in and of itself. This box right down here, CloudFormation. Is anybody familiar with like CloudFormation, or do you talk about infrastructure as code? Oh, yes. Wow. Do you talk about like infrastructure as code in any of your classes? So basically everything here that you see here is provisioned and managed through an API, right? When you go into Amazon and you go into the console, that console is driven by the API that you can access with the command line. So this means that there is a whole suite of tools and pseudo programming languages like Terraform and serverless, there's like a missing E in there. CloudFormation, a bunch of other stuff that actually allow you to write declarative configurations as code. And then you can say, okay, here's my entire infrastructure, apply. And then it converts your code into API calls. It calls the cloud provider's API and it builds all those resources. So really, you should be version controlling all your infrastructure. You should be writing your infrastructure in code and then version controlling it along with your application configuration and your application code. So then this thing burns to the ground, you don't care. You can just re-provision it as long as Amazon Web Services is still there. You accidentally delete the database, whatever, like you have it in code, it's version controlled. You can just revert the commit and push it back up there again. This is incredibly powerful. I really recommend looking at Terraform. Terraform is a multi-service, multi-cloud infrastructure as code tool from HashiCorp. It's incredibly powerful. CloudFormation, if you're using Amazon, is incredibly powerful because everything in Amazon's a first-class citizen for CloudFormation. It can control everything. But yeah, infrastructure as code, incredibly important for any kind of scalable operations. So there you go. This is my view of taking your hackathon application and taking it from this hackathon to a global web application and achieving market dominance, which I recommend you do. So like these tools are all available. There's tons of documentation, books, white papers, tutorials, YouTube, you know the drill. And you have this at your fingertips, which is amazing. Like you don't need to buy a data center and like rack thousands of servers and like lay fiber in order to have a globally present web application. You just need to like write some YAML. Like it's incredibly powerful. This is why the cloud is one of the reasons why the cloud is just such a huge game changer, because there's no capital expenditure. You don't have to buy stuff. Like you just pay for operations and there you go. Sorry, aside. Thank you. Somebody clap? No. All right, so what's next? I just said all this stuff. You know, there's just a lot here, right? But luckily there's tons of awesome documentation and resources for every little bit of this. But really learn infrastructure as code. It's incredibly powerful. Also something you might not learn in school like testing. Everybody has all that. All right. And then I had some recommended reading that I wanted to suggest if people are interested in these kinds of topics and want to learn more. The Phoenix Project is awesome. It sounds incredibly nerdy, which it is, but it's literally a novel about IT and about like how to achieve DevOps, and it's super compelling and will, I think, like give you a better picture into what it's like to work in the industry than any textbook. Super good. A lot of people have read this. This is more nitty-gritty practice of cloud system administration, but it talks about all these concepts and scalability and patterns for all this. Clean architecture is more software architecture, but Bob Martin's very well known for clean code, which is sort of canonical. And then this is clean architecture. And then finally, of course, the necessary 3 O'Reilly books. Infrastructure as code, super powerful. If you haven't really heard of SRE or site reliability engineering, that's Google's approach to operating scalable systems. This book is like a seminal piece of operations literature that changed the way the industry worked when it came out. I highly recommend reading it, or parts of it, you know. You don't need to read the whole thing. It's like set up as a series of essays and articles, it's really good. And then Sam Newman's Building Microservices is a great introduction to microservices architectures and all the concepts. And a lot of this stuff is sort of like technology agnostic or language agnostic. It's more focused around principles and patterns that you can apply in a huge variety of situations. Cool, so I realized that I maybe moved pretty quickly through that, but that's my approach to productionizing your hackathon application and achieving global dominance through operational excellence. So I'm happy to take any questions or just like chat or whatever, so. Great, thank you. Questions? No?